is a quadratic equation? Well, a quadratic equation is an equation which can be written in the form ax squared plus bx plus c equals 0, where a, b, and c are constants and a is not equal to 0. So if we can write it like this, then it is a quadratic equation. So let's try that out. Which of these are quadratic equations? Well, let's try it. This here, can we write it in this format? Well, we've got something x squared, we've got something times x, so that's good. Plus something, well, that something can just be 0. This equation is exactly the same as this one. I've just added 0, and that doesn't change it at all. It just makes it look different. And for a number at the front, it says we need an a here, something times x squared. That could just be 1, because writing a 1 times x squared is the same as x squared. It looks different, but it is exactly the same equation. So this is a quadratic equation, where a is 1, b is 2, and c is 0. This one here, it looks like it doesn't have some of the other terms, but that's okay. We can just say that this is 9x squared plus 0 times x plus 0. Can you see how these two here are exactly the same equation? Adding 0 doesn't change the left-hand side. And adding 0 times x, well, 0 times x is guaranteed to be 0. 0 times anything is 0. So this is saying 9x squared plus nothing plus nothing. And of course, that's the same as 9x squared. So I've written the left-hand side in a different way, but it is equivalent. And now we can see that yes, it is a quadratic equation, where a is 9, b is 0, and c is 0. So it doesn't have to have an x term, and it doesn't have to have a constant term, a number. They can be left out, and it will still be a quadratic equation. This one here looks quite different. Why does it look different though? I suppose one reason is that this says equals 0, but this one, the right-hand side, is not 0. But that's okay, we can move this x squared to the other side. What's really happening is we're subtracting x squared from both sides. Or another way of thinking of it is that this was a positive term, I move it to the left-hand side, and it becomes a negative term. Okay, so 9 times x, take x squared equals 0. Now, just to be consistent with the way that we normally write quadratic equations, which is with the x squared term first, let's get this minus x squared term and move it to the front. So now it's minus x squared plus this term here, because this term is positive. You can imagine there's a plus sign in front of it. There is no c here, there's no constant term, so we can just say plus 0. And again, that's the same, it's equivalent. I haven't changed the equation, I've just changed how it looks. It is equivalent. I've moved the order around, which keeps it equivalent, and I've added a 0, which also keeps it equivalent. Right, so it looks like we've pretty much done. We've got a quadratic equation, which means that the original one was a quadratic equation as well, because the original equation here and this equation here are exactly the same equation. They're just written differently. The value of a is the coefficient of x squared, and the coefficient is negative. Well, if there's no number there, you can imagine it as negative 1. Because 1 times x squared is the same as x squared. So in this one, a is 1, b is 9, and c is 0. Finally, I've sort of given away the answer to this last one. I've got an equation that says 2x equals 0, but this one definitely is not a quadratic equation. Why? Because the coefficient of the x squared term can't be 0. Sure, it's okay if there's no x term or no constant term, but it definitely has to have an x squared term. With no x squared term, it's not a quadratic equation. So now, hopefully, you know how to tell whether something is a quadratic equation, like this, or this, or this, or whether it's not a quadratic equation, like this. And also, hopefully you've learned that equations can be written differently, but still represent the same equation. Until next time.